Okay, so this will be your pre-lab, something that you can follow so you can finish your Eggspress Lab Report. You won't be graded on your project unless you turn in this report. So the objective is to analyze the change in momentum of objects during collision, and we will prove that the law of conservation of momentum is applied in our project. Okay, so you will begin sketching the before collision and after collision setup of your project. On the before collision, your project is on top. You will label that mass of A and the speed of your project VA. Now the height from the bottom on the floor to the initial point of the ramp is the H that we will use to solve for our potential energy later. The blue cart at the bottom of the ramp will be considered as object B, so we'll label it MB and VB for its speed. The after collision setup, your project now stayed at the bottom of the ramp, so notice the apostrophes because we are now considering the after setup of the collision, and your cart should be in a distance away from the ramp. It will be labeled MB prime and VB prime for its momentum. Alright, so for part A, you will get your project with the egg on it and go to the weighing scale and get the mass. So say for instance, this is an example. Do not copy this unless you have the same data. So if you get 350 grams, you will change that grams into kilogram, divide that by 1000, so that will be 0.350. You don't need to use a triple beam balance. This is the exact weight of our blue cart, so you can go ahead and copy this, 1000 grams, and when we change that to kilogram, it will be 1. Alright, now for number 3, you are ready to solve for the speed VA of your project as it goes down the ramp. So in order to get this, we will review our law of conservation of mechanical energies. We will be using our PE equals KE. So at the top of the ramp, we will solve for the potential energy of your project. Mass of your project times 9.8 times the height of the ramp from the bottom or from the ground. So this is just an estimate here because I don't know exactly what's the height of our ramp. Let's say it's 1.5 meters. You multiply that by 9.8 and the mass of your project. So I got PE here equals 5.1. So make sure you measure using our meter stick the height of our ramp from the initial position. Okay, with that, because your project stopped at the bottom of the ramp, we can assume that the potential energy there will be equal to the kinetic energy. So using our equation V equals the square root of 2 times KE divided by M, here's my solving. So 2 times the potential energy, which is this, divided by the mass of your project, that will give you 5.4. Okay, and again, remember to double your parenthesis here when you put that in your calculator, and go ahead and just use the common times sign in between. Okay, therefore our VA is 5.4. You can go ahead and label this here now. So this will be 0.350 kilogram, and your VA is 5.4 meter per second. Okay, now the mass of the cart is 1 kilogram, and since the cart is initially at rest, your VB will be 0. Okay, I want to see this on your sketch. Alright, now let's take a look at the analysis of the after collision. So open that. Okay, most likely your collision will be elastic, so you will only answer numbers 6 and 7. If after collision your project stuck with the blue cart or went over the blue cart and then they moved together, entangled, then that would be inelastic, and you will skip 6 and 7 and do number 8. Now you will check with me if that happens, but most likely it will be elastic. So let's go with this. Alright, so since the Eggspress normally stops after it hits the blue card, then the VA prime of your project will be 0. So at the back, you go ahead and put 0 here. The mass of your cart didn't change. It will still be 350 kilogram. The mass of your blue cart is still 1 kilogram. And now we will solve for the speed of the blue cart after collision. Okay, so here it is. Based on our law of conservation of momentum, the total momentum of the Eggspress and the blue cart before is equal to the total momentum of the Eggspress and the blue cart after collision. So solving for VB prime, we isolate that variable. You will copy again the right side of your equation, move MAVA prime to the left, so that will be negative, and then divide MB for overall. Alright, so substituting the numbers there. Okay, be careful to look. Notice that the momentum of the blue cart before collision is 0. Okay, because it's not moving. And the momentum of our Eggspress after collision, because it stayed at the bottom of the ramp, it stopped, is also 0. So that makes your solving pretty easy. Just get the momentum of the Eggspress before collision divided by the mass of the cart, which is 1. So I got 1.89 meter per second. I'm going to use that and label my sketch at the back. Alright, now that we have solved for the speed of the blue cart, we're ready to look at the impulse. Impulse is the change in momentum. So for part B, we will separate the egg from the Eggspress. So you will remove your egg and you go to the weighing scale and measure the egg's weight. Alright, my example here is 60 grams, so that would be 0.060 kilogram divided by 1000. Okay. Alright, and then remember that you use your stopwatch to get the time of travel from the initial position all the way to when your Eggspress stopped at the bottom of the ramp. So you get that time. For example, it's 2.5 seconds. So here it is what you're going to do. Alright, the final speed of the egg is the VA prime. So that was 0 because eventually it will stop. The initial speed of your egg, because it was on your Eggspress, will be the same as the initial speed of the Eggspress. Okay, so before it hits the blue cart, we solved that VA was 5.4 from part A, so that's your VI. Alright, rearranging this equation, you'll come up with the force, which is this. So mass times the final velocity, which is 0, minus the initial velocity. So you know that your egg was slowing down, eventually stopped. You will have a negative force there, divided by time. Alright, so it's 0.13 newtons. Just copy the answer and put it on the next page. And now to solve for impulse, it's force times time. Your force, which is 0.13 negative, times the time, will give us 0.325. So this is actually a negative number. Alright, go ahead and answer the questions. Make sure you have a conclusion. That way you can get 100 points. -10 if you don't have a conclusion. Hope this helps.